Hi. Today we're going to be going over polynomials. Now polynomials are a very, very, very important part of algebra. They're the core of what we think about when we think about most of algebra. And today I'm hoping to give you like a pretty solid foundation of what polynomials are, and hopefully help clarify what you think polynomials are and how to work with them when you're dealing with them in problems and in learning that you're going to go on beyond just the simple subject polynomials. So, what are polynomials? Well, we can kind of tell by the word. Now, polynomial is a Greek word, and it has two parts. The poly part and the nomial part. The poly part means many, and the nomial part means terms. So polynomial literally means many terms. Many terms. What exactly does that mean? Does that mean different types of definitions of words? Because terms usually means like a vocabulary term. No. In this case, terms has to do with certain groups of numbers and variables. So let's give an example of a polynomial. Say I have x, my variable, cubed minus 6x squared plus 5x minus 7. Right? Here, each grouping of x is a term. So we have 4 terms in this equation, including 7, of course. Here we have x cubed, right, x by itself. Here we have x squared with a coefficient, or thing next to it that's being multiplied by x squared, of 6, negative 6. Here we have x with a coefficient of 5, and here we have negative 7. And you might say, well, negative 7 doesn't have an x. Well, we still consider it a term, because we could write this as negative 7 times x to the 0. And we of course know that anything to the 0 is 1, so in the end we do get 7 to the 1, or just negative 7. Right, so that's also a term. So if I had, let's say, another polynomial, like 7x to the 10 minus 5x to the 4 plus 2x squared. Here, that's one term with an x and a coefficient. This is another term with an x and a coefficient. This is another term with an x and a coefficient. And now you notice we don't have like a countdown, right? In the previous one we had 3, x to the 3, x to the 2, x to the 1, x to the 0. Here we have x to the 10, then x to the 4, then x to the 2. We don't necessarily have to have all the x to the power lined up in a in descending order, right? We can jump around a bit, so long as we group different terms together, right? If we had something like this, and then let's say plus 3x squared, well then we can combine that and combine like terms, since we both share an x squared, and we can turn that just into 3 plus 2, or 5x squared. But we can't combine it with any of the other terms, since none of the other terms are x squared. And now we're getting to the second important element of polynomials that you use a lot, which is called their degree. Their degree basically means what's the power, what's the exponent of the x with the greatest exponent, right? What's the maximum x exponent that there is? All right, so in this case, the maximum x exponent, right, the highest value that x is raised to the power of is 10, right? And here we raise x to the 10, and 10 is greater than 4 or 2, so our degree, you might say, is just 10. And of course, with different problems, you have different degrees, right? If we had a polynomial like 3x to the 14 minus 7x to the 10, well, here we have 2 terms, and we look for the highest exponent power, which is x to the 14. So we have 2 terms, and the degree is 14. And of course, always, always, always remember to combine like terms, right? Because this x may seem kind of weird and strange, but it's really just a standard, like a standard number. It's just a representation of a number, which means if you have, you know, two terms or two parts with the same x, you know, x raised to the same power, you can combine them, right? We can do things like 6x cubed plus 5x cubed. We can combine them because they both share an x cubed into 11x cubed. Similarly, we can subtract. We can say, okay, 9x to the 4 minus 4x to the 4 is just 9 minus 4, which is 5x to the 4. So long as we have the same x terms, right? X raised to the same power, we can do addition, subtraction, multiplication, division, just like we normally would with the things attached to the x's, what we call coefficients. And that's the basics of how polynomials work and how we express them. Just remember, simplify what you can if you have x's with the same powers. Organize your polynomials from highest degree down to lower, right? So we would have something like x to 14 minus 7x to the 10 minus, say, 3x to the 4, going down in decreasing order. And degrees, and the degree of the polynomial is whatever power you raise x to that's the greatest, right? So in this equation, in this expression, for example, we have a degree of 14. In something like this, we would just have a degree of 4, since there's no other term. Or like this, we'd have a degree of 3, since there's no other term. If we had something like 6x squared minus 7, we'd have, a degree of 2. But if we had added on to it 12x to the 1,000, then we'd have a degree of 1,000. And all of these are very, very important to a variety of mathematical things you can do with polynomials, which we'll explore later. I hope you found this helpful. I hope you have a great time with your math, and thanks for watching.